Hello everyone, so today we are going to learn about the axis deviation in ECG. So I'm going to share with you a very simple and easy trick to learn about the axis deviation so that you won't be able to forget it, okay? So basically you will remember it for a very long time. So we will start with the leads. So out of all the leads present in the ECG, we will be focusing especially on the lead number 1 and AVF, which gives the vector of the leads in the phone. So basically we are focusing on 1 and AVF, and a vector of the current passing through these two leads will give us the direction of the deviation. So if the net current flowing in this direction, it will be considered as normal. But if there is a deviation in this quadrant or this quadrant, there will be deviation called as left axis and right axis deviation respectively. So if the current is deviated in this particular quadrant, we will say that it is a left axis deviation. Now if we talk about left axis deviation, we have two types of left axis deviation. If the deviation is between 0 degree and minus 30 degree, we will call it as the physiologic left axis deviation, which is supposed to be present in the normal human beings. Like if a female is pregnant, she will show the left axis deviation, she might. And if there is an elderly person, or if we are having an ECG of an athlete. Now if there is the deflection in from minus 30 to minus 90, we will call it as a pathologic left axis deviation. Now the deviation in this area, anywhere in this area, is a matter of concern. About right axis deviation, any deviation from 90 to 180, any deviation in here will be considered as the right axis deviation, and there is no such thing like physiological or pathological axis deviation in case of right axis deviation. Now there is third criteria of deviation, which is extreme deviation, and it is a very rare case. You will hardly find any ECG with extreme deviation or deviation in anywhere in between this quadrant. Okay, now I will show you the trick of how to learn the left axis deviation. So for pathologic and physiologic, I have already told you the examples that elderly, pregnant or pregnant female or athletes can show physiologic, and pathologic can be anything between minus 31 to minus 90 degree. So basically pathologic can be seen in left bundle branch block, left ventricular hypertrophy, ventricular tachycardia, even emphysema you can find this case. Now the main trick which is supposed to be understood by you is that if we consider lead 1 and AVF in ECG, you will find that the wave in lead 1 will be upright and the wave in AVF will be inverted. So this means that there is a left axis deviation, and you will learn the thing with the character left leaves. So you can see left leaves, both these waves, one is going downward and one is going upward. So you can learn this by that these two waves are opposing each other and they are going away from each other. Now we'll talk about the right axis deviation, which is supposed to be somewhere here. So about this, the deviation is something like the lead 1 you will see in the upright direction, and AVF you will also see in the upright direction. It means that right reaches, so both these waves will try to reach towards each other, and it can be easily seen in the COPD, right bundle branch block, right ventricular hypertrophy, and ventricular tachycardia as well. So ventricular tachycardia is common in both the LAD and RAD. Now there's a third kind of deviation, indeterminate, or you can say the extreme deviation, about which I talked that it is a very rare case. You won't generally be observing this kind of ECG. So in the lead 1 it is inverted, also lead AVF it is also inverted, so both of them are inverted. So if you have trick to learn the left axis deviation and right axis deviation, you will keep in mind about the indeterminate, although it's a very rare case. In this, both the leads face downwards, the waves face downward, and it is generally observed in ventricular tachycardia. Okay guys, this was it for the video. Thank you for listening to the video. If you like the video, do press the like button, subscribe and share with your friends. Thank you so much.